eet105, chapter 12, section 7, Ampere's circuital law. The corollary to this is KVL. That's Kirchhoff's voltage law. It's that is the sum of the voltages in the loop equals zero. This is the sum of the magnetomotive forces in the loop equals zero, which is in ampere turns or Gilbert. So the sum of the forces in equals the sum of the forces out. And then the force equals Ni, which is equal to phi times R, which is also equal to H times L. Ni equals HL is going to be used a lot here. So to show you an example, this is the sum of the loop, sum around the loop of the forces equals zero. So Ni is your rise. This is your input energy here. And then this is a drop. So this is H of AB, the magnetizing force, times L. This is the length from A to B. So where they're starting is right here. It doesn't really matter where you start, but again, they're starting at point A, and then the length around this loop from A to B is from here to here. So it would be this distance plus this distance. And then it would be the H of steel. They're calling it H of AB, but it's of this material steel. Minus H of BC, which is the cobalt. So it's this distance from here to here, which is the L. And then the H is of H of cobalt. Minus HCA, which is of this iron piece, the H of it, times the length of it, which would be this distance plus this distance plus this distance equals zero. So when you simplify this, you get this equation over here, which I was calling the sum of Fn equals the sum of F out. So this is the impressed magnetomotive force, the force in. This is the force out, sum of the drops. So part 8 is the sum of the fluxes equals the sum of the flux in equals the sum of the flux out per core junction, with phi being the flux in Webers. And then 12.9 series magnetic circuits determining Ni. Again, the sum of the forces in the loop equals zero. Sum of force in equals force out. So use the same formula as part 7. Section 7, use above formula with variables given to find the variables not given. Same as formulas in section 12.7. So the difference between 12.9 and 12.7 is you're usually given what N and I are here. And you have to figure out what H is. Sometimes you're probably given what L is, but you have to figure out what H is, and whatever variable that you're not given, that's the one that you need to look for. So in this one, maybe you're given what H and L is, and maybe what N or I is, and then you have to figure out what Ni is. And then 12.10 is air gaps. So if you have an air gap in your core, example looks something like this in the book. Let's see here. This would be an air gap in the core. So it's just an interruption and a continuous core by a gap. So if you have an air gap, you have to figure out what the force across that gap is. So B equals mu H. H equals then B divided by mu. Hg is the magnetizing force due to the air gap, and Bg is the flux density due to the air gap. Okay, it's just what is it? The subscript is G because it just means gap, and then mu 0 is 4 times 10 4 pi times 10 to the negative 7th Webers per ampere meter. And then they have 1 over mu 0, which is just as reciprocal. And a lot of times mu 0 is in the denominator. That's why they do that. Is 7.97 times 10 to the 5th. Okay. So we'll go over a problem on how to figure that out.